Good morning, students. Welcome to online classes from MGVC Arts, Commerce and Science College, Mudde Bihar. Its Department of Chemistry. Myself, Professor UMARFAROOQ HALYAL, going to take your BSc III Sem class. The unit is Acids and Bases. As we know, in previous class, we discussed regarding to Arrhenius concept of acids and bases, Bronsted-Lowry theory of acids and bases. Here, according to Arrhenius theory, we know that acid is a substance that gives H plus ions in water, and base is a substance that gives OH minus ions when dissolved in water. Like that, according to Bronsted and Lowry theory, an acid is defined as it is a substance which can donate a proton, and a base is a substance which can accept a proton. And today we are moving to the advantages and disadvantages of that theories. Now coming for advantages of Arrhenius concept. According to Arrhenius concept, neutralization reaction according to Arrhenius concept, it is the combination of H plus ions of the acid and OH minus ions of the base to form water. That means when we take two substances as reactants, so that two reactants combine with each other and one gives H plus ions from their acid and another reactant that gives OH minus ion from their base. Here the formation of water. The example, Na plus OH minus, that is in aqueous phase, that combines with HCl, that is also in aqueous phase, that gives us NaCl aqueous. Here sodium ions, that is in a positive form, and Cl, that is in negative, and along with that the release of water molecule. The second advantage of Arrhenius theory, the sodium hydroxide aqueous is reacting with hydrochloric acid, that is also aqueous. Here the formation of again sodium chloride, aqueous, and water. Here delta H is equal to minus 57.3 kilojoules. Delta H means change in enthalpy. Second one, KOH, potassium hydroxide aqueous, that is reacting with HNO3 means nitric acid, that is also in aqueous phase, that gives us potassium nitrate, that is KNO3, and water. Here the delta H is also minus 57.3 kilojoules. Cancelling the common ions on both sides of the equation, we get OH minus plus H plus, that gives us H2O. Here again, as we compare to the second example, OH minus plus H plus, that gives also H2O. This gives us the neutralization of a strong acid by strong base by combination of OH minus and H plus ions to form H2O. Here the delta H is always constant, that is minus 57.3 kilojoules. Now moving disadvantages of Arrhenius theory. According to him, it can be applied only to reactions that occur in water because it defines acids and bases in terms of what happens when compounds dissolve in water or aqueous solution. Number 2, it does not explain why some compounds in which hydrogen has an oxidation number +1, such as HCl, when dissolve in water to give acidic solutions, whereas others do not give. Number 3, only the compounds that contain the OH minus ion can be classified as Arrhenius bases. This Arrhenius theory can't explain why other compounds such as Na2CO3 have the characteristic properties of bases. Now moving the advantages and disadvantages of Bronsted-Lowry theory. Here the advantages: this concept can explain the acidic and basic nature of a substance in aqueous medium as well as other protonic solvents like liquid ammonia, etc. And the next one, it can also explain acid-base reaction taking place in gaseous phase. This Bronsted-Lowry theory is also reaction takes place in gaseous phase as well as aqueous and other protonic medium. Now moving disadvantages. It cannot explain the acid-base reaction taking place in non-protonic solvents. The next one, substances like boron trifluoride, aluminum chloride, etc. do not have any hydrogen and hence cannot a proton but are known to behave as acids. Here the substance like BF3 and AlCl3, they does not contain any hydrogen but also they have act as acids. Now moving next theory, that is Levy's acids and bases. According to Levy's, acid is a substance which can accept a pair of electrons and base is a substance which can donate a pair of electrons. And here in this Levy's acids and base theory, the formation of covalent bond is possible very much. And here in this one, many Levy's acids, they do not contain hydrogen and they also acts as Levy's acids. Here the example: molecules in which central atom has vacant orbital BeF2, that is Levy's acid, plus 2F minus, that is Levy's base, that gives us Be4 2 minus, that is adduct. Here beryllium atom in beryllium fluoride molecule has only 4 electrons, that is incomplete octet, and hence it can receive electrons from F minus to attain octet configuration. Number 2, molecules whose central atom is linked with more electronegative atom by double bonds. Here example: O delta minus, that is equal to carbon 2 delta plus, that is equal to O delta minus plus OH minus, that is Lewis base, that gives us HCO3 minus. Limitations of Lewis concept. It is not possible to arrange the Lewis acids and Lewis bases in any order of their acid or basic strength. This is because the strength of Lewis acids and bases, they are depends on the only type of the reactions, and they do not absolute power of accepting or donating a pair of electrons. The first limitation means it does not depend upon their strength of the Lewis acids and base. It only depends upon the type of reaction. Number 2. The conventional protonic acids such as HCl, H2SO4 are not covered under Lewis concept. The second one. Some conventional protonic acids such as hydrochloric acid and sulfuric acid, they are not coming under this Lewis concept. And the third limitation, the reactions between Lewis acid and Lewis base should be fast, but it is not so in actual practice. Here, the third limitation, the reaction between Lewis acids and bases are very fast, but actually when we are going to try with our lab, on that case this is very much slow. Now the next concept, that is solvent system concept. According to this concept, acid is a substance which gives solvent cations when dissolved in the solvent. Here, acid is a substance which gives solvent cations when dissolved in the solvent, and base is a substance which gives solvent anions when dissolved in the solvent. That is nothing but base is a substance. When this base, when we are going to dissolve in solvent, that gives us anions. The example, autoionization of water. As we seen, water is amphoteric in nature. In pure water, a few molecules act as bases and few act as acids. Because of that, this water is called as amphoteric in nature or universal solvent. Here water plus water, that gives us H3O plus, that is aqueous medium, and OH minus, that is aqueous in medium. This is referred to as autoionization. This is we are going to refer as autoionization. Now applications of solvent system. The acidic or basic nature of a given substance in a given solvent can be explained by the given example. Here acetic acid behaves as a weak acid in water due to feeble ionization. Here acetic acid as a weak acid. Take below CH3COH, that is acetic acid, weak acid plus H2O, that gives us in the reversible reaction H3O plus, that is protonium ion, plus CH3COO minus, solvent cations in low concentration. But acetic acid, when dissolved in liquid ammonia, it is completely converted into ammonium ion, that is NH4 ion, and this is acid ion, and therefore this acetic acid behaves as a strong acid in liquid ammonia. See below, acetic acid, that is strong acid, plus NH3 solvent, that gives us NH4 ion, that is acid ions, along with that CH3 COOH, acetate. So see here, students, here when acetic acid is dissolving in water, on that time it acts as weak acid. Certainly same acetic acid when dissolving in liquid ammonia, in this case it acts as strong acid. The second one example, sulfuric acid is completely ionized in water to produce H3O plus ions, that is protonated water, and hence it acts as a strong acid in water. Here is H2SO4 sulfuric acid plus 2H2O, that gives us 2H3O plus ions plus SO4 2 minus sulfate ions. When it is only the completely H2SO4 sulfuric acid is ionized in water, that produces H3O plus ion. Again, when sulfuric acid is put into liquid HF, hydrogen fluoride, it is ionized to produce fluoride ions, F minus ions, that is solvent anions, and hence H2SO4 behaves as a base in liquid HF. You see here, sulfuric acid is base plus HF, hydrogen fluoride, that gives us H3SO4 plus solvent ion, that is F minus. Now disadvantages of solvent system concept. Acid-base reaction taking place in the absence of a solvent cannot be explained. This cannot account for the acid-base reactions occurring in non-ionizing solvents like C6H6, CH, Cl3, etc. Okay, enough for today class. Watch and share with your friends, and also subscribe this YouTube channel to get regular updates of your class videos. And in next class we are going to discussing about in the same acid base chapter, that is Pearson's HSAB principle, that is Pearson's hard, soft, acid and bases.